sigma dA. Okay. What is the sigma value? Sigma is equal to sigma naught r cos theta into yes. Suppose you can take the system is a cylinder. Cylinder. Okay. Cylindrical system. Then what is the value of dA? dr into r d theta. Yes or no? dr into r d theta. Okay. Sigma naught we can take common out. Next, this r, this become r square dr. Into next cos theta d theta. Okay. R varying from
0 to capital R.
0 to capital R.
To
Okay.
infinity.
And theta varying from 0 to
2 pi.
0 to 2 pi. Okay. R square integration. Sigma naught
R cube by 3.
r cube by 3. Okay. And cos theta integration.
Sin theta.
Limit 0 to 2 pi. Okay. Sigma r cube. Sigma r to the power 3.
0 is
3. Okay. Sin theta. Sin 2 pi minus sin 0. Sin 2 pi minus sin 0. Sin 2 pi 0. Sin 0 0. 0 minus 0. 0. Is how much is charge enclosed by the system is equal to how much? 0.
0.
Next. Sigma is equal to sigma naught r cos square theta. Sigma is equal to sigma naught r cos square theta. Yes. Sigma is equal to sigma naught r cos square theta. System 1D, 2D, 3D.
2D.
System is a 2D, okay. System 2D, then Q is equal to how much? Q is equal to sigma dA. Q is equal to sigma dA. Integration sigma dA. Yes, what is the sigma value? Sigma is equal to sigma naught r cos square theta into dr r d theta into dr r d theta. Okay. Sigma naught we can take common out. Integration r square dr into
cos square theta d theta.
R varying from again 0 to capital R.
0 to capital.
Okay, and theta varying from 0 to 2 pi.
0 to 2 pi.
Then sigma r integration r cube upon 3.
By 3.
Means we can substitute limit sigma r cube upon 3 into cos square theta. Cos square theta integration. How to solve this cos square theta? Cos square theta can be written as 1 plus cos theta upon 2. Okay. Integration into d theta. 1 by 2 we can take common out. Okay. Limit 0 to 2. Then sigma r to the power 3 upon 3 into 2, 6. Integration 0 to 2 pi. 1 plus cos 2 theta into d theta. 1 plus cos 2 theta into d theta. Okay. Sigma r to the power 3 upon 6. D theta integration theta limit 0 to 2 pi. First one. And second one plus cos theta integration sin 2 theta upon 2 limit 0 to 2 pi. Okay. Sin 2 pi 0 minus sin 0 0. With this part is equal to how much? 0. And this is equal to how much? Sigma r to the power 3 upon 6 into higher limit 2 pi minus lower limit 0. Okay, 1 to get cancel. Then this is equal to how much? Pi sigma naught r to the power 3 upon 3. This is the Q value for system is 2D. 2D case, both cylindrical as well as spherical, we getting the same answer. Yes or no? Why? Because dA value will be same. Just we can, notation will be changed. Here sometimes we can take the rho, sometimes we can take the r. Okay, r and rho both are same for cylindrical case. And we getting q value also same for cylindrical as well as spherical system. This is for 2D case. Okay, next 3D case. 3D system is a cylindrical system. Cylindrical system, cylindrical. Then what is the value of dv? dv, first length element, d rho, second length element r, rho d phi. Okay, second length element
Rho d phi.
rho d
Rho
phi,
d phi.
rho d phi, and third integration, third length
dz.
element dz. Okay, this system is a cylindrical system. Next system is a spherical system. Spherical. Okay, spherical system dv, dr, r d theta, r sin theta,
d phi.
r sin theta
d phi.
d phi. Okay. Suppose rho is equal to kr, rho is equal to kr, or rho is equal to k rho. Suppose rho is equal to how much? K rho. Here rho means not a radius, here rho means a density. Okay, rho is equal to how much? Rho naught, rho naught, rho. Okay, what is the value of q? This rho is equal to rho naught rho. In which region 0 is less than, rho is less than. Suppose the radius is a, suppose, or okay, write down a is the radius. Means this one is a cylindrical system. Okay, this one is a cylinder having radius is how much? Rho. Means this charge density varying from this 0 to a radius rho, radius a. Okay, means charge density varying from 0 to radius a. Got it? Next, q is equal to how much? Q is equal to, system is a 3D. Here system is non-uniform. We can dq upon dv formula. Okay, rho into dv. Rho into dv. What is the value of rho? Rho is equal to rho naught rho. And what is the value of dv? dv is equal to d rho d phi dz. d phi dz. Okay. Suppose the length of cylinder is L. Length of cylinder is L. Okay. Next, rho naught constant. Take one out. This row become rho square d rho. Second one d phi. Third one dz. Okay, d phi dz. Rho varying from 0 to radius of the cylinder. 0 to radius of the cylinder. Okay, means 0 to a. Pi varying from 0 to 2 pi.
0 to 2 pi.
And z varying
0
from
to L.
length of
0 to
cylinder.
L.
Suppose we consider length of cylinder is L. Okay, and this is equal to how much? Rho naught. Rho square integration. Rho square integration.
A cube by 3. A cube by 3.
Rho cube by 3. Rho cube by 3. Limit 0 to a. Okay. Next, d phi integration. D phi integration.
2 pi.
0 to a. Okay. D phi integration phi. Limit 0 to 2 pi. And dz integration z. Limit 0 to L. Substitute 1 by 1 value. Rho naught. Rho naught.
A cube by 3.
A cube by 3. A cube by 3. Second one 2 pi. Third one simply z or L. This is equal to how much? Rho naught a cube 2 pi L upon 3. This is the value of charge. Next, rho is equal to, again say suppose rho is equal to kr. Rho is equal to kr. Okay, rho is equal to kr in which region? 0 is less than, r is less than a. Now system is a spherical sphere. System is sphere. System is sphere. We know that d tau is equal to, rho is equal to how much? This one is non-uniform. Then we can use this formula, dq upon dv. Then what is the value of dq? dq is equal to rho dv And what is the Q value? Q is equal to integration rho into dV. Rho value. Rho is equal to how much? Kr. Rho is equal to Kr. And what is the dV in a spherical system? Spherical system. Dr r d theta r sin theta d phi. R sin theta d phi. Okay. K take common out. This r and this r and this r. This become r to the power 3 dr. Okay. Limit 0 to radius of the sphere. Radius of the sphere is a capital R. Okay. A radius of the sphere is how much? Capital R. 0 to okay, 0 to A. Next, sin theta, d theta. And third one is d phi. Okay, theta varying from 0 to pi. Pi varying from 0 to 2 pi. Okay?
0 to 2 pi.
R cube integration. R cube integration. R to the power 4 upon 4. Limit 0 to A. Next, sin theta integration minus cos theta, limit 0 to pi, and d phi integration pi, limit 0 to 2 pi. 0 to 2 pi. Got it? Next, k a to the power 4 upon 4 sine, okay, minus cos pi minus cos 0. Cos pi minus cos 0. Okay. Pi 2 pi minus 0. 2 pi minus 0. Okay. 2 pi minus 0. Yes. K a to the power 4. K a to the power 4 upon 4. Okay. Cos pi minus 1. Cos 0 plus 1. But outside is minus.
Plus 1.
Minus 1 minus 1. Minus 2. Minus 2 into minus 2. Minus 2 into minus 1. Plus 2. Okay. Into 2 pi. Into 2 pi. Okay. This 2, 4 get cancelled. This is equal to how much? Pi k a to the power 4. Pi k a to the power 4. This much amount of charge present on sphere. This much amount of charge present on sphere. Okay, next. Electric field, we can solve this one. What is the electric field? For symmetric, continuous, for asymmetric, continuous. Yes or no? Yes, we can solve or not?
Yes, sir.
What is the electric field? For continuous. Continuous, symmetric, asymmetric. Solve के लेगा अपन है?
Alkaline.
Okay.
Symmetric.
Yes.
Symmetric.
Yes, बोला. What is the electric field?
Symmetric, sir. Charge distribution.
Electric field. Yes. K lambda pa. K lambda. Yes. Symmetric. K lambda. What is the answer? Electric field for symmetric case, answer
K lambda upon R square. R square.
yes. K lambda. a thin rod, electric field. I don't directly memorize these two formulas. Electric field. E perpendicular and E parallel. E perpendicular is equal to K lambda upon Z. K lambda upon Z. Okay. K lambda upon Z. Sin theta 1, sin theta 2. Sin theta 1 plus sin theta 2. This is the angle at where we need to find out the electric field. म्हणजे ज्या पॉइंट आपण इलेक्ट्रिक फील्ड फाइंड आउट करतोय त्या पॉइंटचे अँगल्स. ओके. And what is the E parallel? E parallel is equal to K lambda upon Z. K lambda upon Z cos
theta 1 minus cos theta 2.
Cos theta 1 minus cos theta 2.
Theta 2.
Cos theta 1 minus cos theta 2. Okay. Suppose this one is a rod. And we can find out what is the electric field at this point. What is the electric field at this point? Okay. Now we're getting where is the alpha 1 and alpha 2? Draw the perpendicular is here. We're getting this alpha and this one is another alpha. Okay. This one considered as a theta 1, this considered as a theta 2. Don't consider here and here. Okay. Means at a point where we can find out the electric field. Where we can find out electric field. Yes or no? ज्या पॉइंट आपल्याला इलेक्ट्रिक फील्ड फाइंड आउट करायचं आहे त्या पॉइंटचे अँगल्स घ्यायचे. थीटा 1, थीटा 2. गॉट इट? E perpendicular and E parallel is equal to K lambda upon Z cos theta 1 minus cos theta 2. For parallel case, for perpendicular case, K lambda upon Z. Z is a distance. Z, which distance? This rod to this point distance. Okay, this distance is known as a Z distance here. Okay. Cos theta 1, theta 2 value is here. Next. Suppose the length of rod is L. Or we can take directly infinite wire. Infinite rod. Okay. Infinite rod. What is the value of theta 1 and theta 2? Infinite rod.
Pi by 2.
Infinite rod. Yes. Theta 1 is equal to theta 2 is equal to how much? Pi by 2. Theta 1, theta 2 is equal to pi by 2. Then E perpendicular.
K lambda.
E parallel. We know that total electric field is equal to how much? Total electric field is equal to E perpendicular plus E parallel. Yes or no? E perpendicular plus E parallel. Okay. E parallel component.
0.
E parallel is equal to how much? Cos theta 1 minus cos theta 2. Cos theta 1, 90. 0. Cos theta 2, 90. 0. 0 minus 0, 0. Is E parallel component 0. Only perpendicular component will be survive, and this is equal to how much? E perpendicular. Total is equal to how much? E perpendicular is equal to, yes, K lambda upon Z. Z is equal to, sometimes we can take the D, suppose D is a distance. Okay. K lambda upon D sin theta 1 plus sin theta 2. What is the theta 1, theta 2? 90, 90. Okay. Now this is equal to how much? 90 plus sin 90. Okay, sin 90 plus sin 90. Sin 90, 1. Sin 90, 1. 1 plus 1, 2. This is equal to how much? K lambda upon D. 2 times direction. Perpendicular. Normal to the rod. Normal to the rod means this one is X axis, Y axis, Z axis. Normal to the rod. This one is X axis, this one is a Y axis. Okay. Normal to the rod means this is Y cap, X cap, Z cap. Means electric field E bar is equal to how much? 2K lambda upon D. 2K lambda upon D. J cap. Okay. Next, one end. One end means one is an infinite end. One is a infinite end. One is a finite end.
एक theta 0, theta 1 0, theta 2 90.
Theta 1 0, theta 2 90. Yes or no? Theta 1. E parallel. E parallel.
Lambda upon E lambda by D.
K lambda by D.
I capture direction मध्ये.
K lambda by, okay, D. E perpendicular.
lambda by
E lambda by D.
K lambda by D. Yes or no? Direction.
J direction, sir.
K lambda upon D. Here we consider this one is a J cap. Here is I cap. Then E net is equal to how much? E net is equal to, yes,
I cap plus J cap.
K lambda upon D. I cap plus J cap. Okay. Next. Suppose they are given two rods. They are perpendicular to each other. Okay, this one is the first rod. This one is the second rod. Okay. And we can take point is here. This is the distance is L by 2 distance. Okay. L by 2 distance. Okay. But here, charge density is a lambda and 2 lambda. But length will be same. Charge density is lambda and minus 2 lambda. Lambda and minus 2 lambda. Yes. What is the value of theta 1 and theta 2? Where we can find out the electric field? At this point we can find out the electric field. Okay. What is the value of E at this point? Okay. This distance is L by 2. Okay. This distance L by 2. Here also L by 2. What is the value of theta 1 and theta 2?
Pi by 4, pi by 4.
What is the theta 1 and theta 2?
Pi by 4 का sir?
Theta 1, theta 2. Yes, this is equal to how much? This becomes like a square. Yes or no? Because this distance is here, this also here. We can take again 2. We getting square. Okay. Then this angle become theta 1, theta 2. 45 means theta 1, 45 degree. Theta 2, 45 degree. Then E parallel.
0.
E parallel K lambda upon. Here what is the value of D? L by 2. Yes or no? Total length is L. Then what is this one? This is half of this one. Means this become L by 2. Okay. Into cos 45. Cos 45 minus cos 45. Cos 45 minus cos 45. 0. Means E parallel. E parallel 0. Next, E perpendicular. K lambda upon. What is the value of D? D is equal to L by 2. Okay. And this becomes sin 45 plus sin 45. Sin 45 plus sin 45. Sin 45, sin 45. 2K lambda upon L into sin 45 1 by root 2. Sin 45 1 by root 2. 1 by root 2 plus 1 by root 2. 2 upon root 2. Okay. Means E perpendicular is equal to E perpendicular first is equal to yes K 2K upon lambda L 2K upon L. Okay. 1 by root 2 1 by root 2. 2 upon root 2. 2 upon root 2. Okay.
K lambda by L.
Yes, 2 root 2 we can divide it by root 2 multiplied by root 2. Then this become 2 root 2 K lambda upon L. Direction. Direction. This one is x axis, this one is y axis. This is x axis, y axis.
Minus y cap.
J.
Yes.
J cap.
Plus x cap minus x cap plus y cap minus j cap.
Minus J cap.
Minus j cap. Why minus j cap?
I'll just write you another diagram.
Minus j cap ni ka asal electric field. Because here they are given charge density lambda here positive negative. Lambda is positive only if charge having positive negative.
Positive.
Positive, yes or no? Charge having positive. This will be positive charge. This one, where we can find out the charge, we consider the take charge. What is the value of take charge? Take charge plus 1. Like and like. Means here, this one is a reference. This one, center. Like and like.
Like
Toward the center, away from the center.
away from the center.
Downward, upward. Downward. Downward means which direction? Minus j cap. Okay. Next, E parallel. E parallel is equal to, yes, 2k lambda upon L. Okay. Yes, this is equal to how much? Cos 45, cos 45, cos 45, cos 45, 0. Or for which line? First line. Okay, first rod. For second rod. For second rod. Second rod. Okay, again second rod. Parallel lines. Yes. Second parallel. Second parallel. 0. Yes,
Zero,
or no?
zero.
Second perpendicular. 2k.
2k lambda by L.
4k
I
lambda.
cap. I cap.
Sin 45 plus sin 45. Direction. Direction
I cap.
plus I cap minus I cap.
Plus I cap.
How?
minus 2 lambda है का सर?
Here is a
minus
lambda,
I
here is a
cap.
minus 2 lambda.
Minus I cap.
Minus I cap कसं येईल?
निगेटिव्ह आहे ना? निगेटिव्ह 2 लॅम्बडा आहे ना?
मग minus 2 lambda जर घेतला इथं k is equal lambda is equal to minus 2 lambda आणि this minus I cap किती प्लस मायनस.
मग प्लस आय कॅप घेतलं पाहिजे सर. तर डायरेक्शन मध्ये साइन घेतो ना आपण?
Attraction repulsion.
मायनस
Attraction repulsion. Like and like.
अट्रॅक्शन
Toward the center, away from the center.
टुवर्ड्स सेंटर.
Toward the center. With the charge moving in negative direction. Okay. And what is the lambda here? Lambda is equal to 2 lambda. Yes, or no? Lambda is equal to.
ये सफिक्स 2 पाई है का? ये सफिक्स 2 पाई इक्वल टू 0 आणि ये कई पैरेलल है सर ते.
Parallel. This one is a parallel. E2 parallel 0 because both the value will be same. Okay. This is equal to how much then? 4k lambda. 4k lambda upon L 1 by 2 1 by 2. 2 upon root 2. 2 upon root 2. Here multiplied by root 2 divided by root 2. Okay. This root 2 1 2 get cancelled. Means this is equal to how much? 2k lambda. So 2k lambda. 2k lambda upon L. Okay. 1 2 get cancelled. And this 2 become 4. What is the 2? Root 2 is remaining. 2 root 2 is remaining. Direction minus x cap. Minus x cap. Okay. Addition of all components. Addition of all components. Yes. First component perpendicular.
2 lambda by L.
2 root 2 lambda. 2 root 2 k lambda upon L inside the bracket. Yes. Inside the
माइनस एक्स कॅप
minus x
2 माइनस 2 एक्स कॅप
minus 2x cap
माइनस जे कॅप.
minus a cap. Yes or no? 2. Same example. Suppose here is a lambda, 2 lambda, 3 lambda, and 4 lambda. A rod length have the same. Okay. Point is here. Point is here. Okay. Charge density lambda minus 2 lambda minus 3 lambda 4 lambda 4 lambda. Okay. For all cases E1 parallel. E1 parallel. Okay, we consider anyone as a 1. E2
Zero,
3
sir.
4. Okay. E1 parallel 0. E2 parallel
0 सगळ्यांसाठी कर.
0 चे
A3 parallel 0. E4 parallel 0. Yes or no? All component, parallel component 0, because we know that cos theta 1 minus cos theta 2. Theta 1, theta 2 will be same. Okay. Find out the E1 parallel, E2 parallel, E3 parallel, add up all components. Yes, for first, like and like. E1 perpendicular direction. E1 perpendicular. Here charge is a plus. Okay, always memorize. Here charge is, sorry. Here charge is plus, here charge is minus. Okay, here charge is minus. Here is minus 3 lambda, means here all charges are minus on this one. Here is a plus 4 lambda, means here charges is plus 1. Here also charges is plus. Okay. Then like and like, here unit take charge plus 1. Like and like. Toward the center, away from the center, means first one in this direction. Second one. First in this direction. Second.
Unlike.
Toward the center, away from the center. Second in this direction. Third one. Third one.
Unlike away from the center.
Toward the center, downward direction. And this is the 4. 4.
Like.
Positive direction.
Yes.
So find out fast E total. E total is equal to how much? E total is equal to E1 perpendicular plus E2 perpendicular plus E3 perpendicular plus E4 perpendicular. Fast. What is the value of D? D is equal to, yes, how much? K dq upon r square. R square is the distance between charge and that point. Charge and that point. Charge means here a ring to that point. This is a z. This distance is r. Then what is this one? This is a simply z square plus z square plus r square. Yes or no? And this is equal to how much? Z square plus r square. Okay, square root get cancel. This is the value of D. This is the value of D. Okay. Then Ex is equal to how much? Ex is equal to integration. And what is the value of cos theta? Cos theta.
Z by square root of r square plus z.
Z by under root r square plus r square plus z square. Yes or no? We can substitute this both value in this equation. Then this is equal to how much? K dq z upon, yes, z square plus r square bracket is to how much? 3 by 2.
3 by 2.
Bracket is to 3 by 2. In this case, which component are constant? In this case,
R.
Kz upon z square plus r square is to 3 by 2.
okay, k is constant. Okay, z constant variable.
Constant. Z
Constant.
Constant.
Okay, k z also constant. Okay, next r constant variable. This is a fixed form, whole circle. Yes or no? And this also constant, means z square plus r square bracket is to 3 by 2. Integration dq constant variable.
Variable.
Okay, q varying
0
from
to 2 pi.
dq
Varying from na. Theta hai na thi?
dq dq integration
dq च्या जागी टाकावं लागेल. लॅम्बडा dx टाकावं लागेल सर.
कशासाठी?
dq साठी
आता या रिंग वरती किती चार्ज असेल?
लिमिट हाफ लिमिट घ्यावं लागेल का?
इंटिग्रेशन dq च्या जागी सर टाकावं लागेल ना सर. लॅम्बडा dx.
0 to q
0 to qn.
total charge q. Yes or no? Can simply derivative integration get cancel. This is equal to how much? Q only. Kq z upon z square plus r square bracket is to how much? 3 by 2. Bracket is to how much? 3 by 2. Whole ring contain how much charge? Total ring contain capital Q amount of charge. Yes or no? Capital Q amount of charge. Yes or no? Means kqz upon z square plus r square bracket is to how much? 3 by 2. Bracket is to 3 by 2. This one is a ring. Okay. at a distance z. Okay, we can find out the electric field at a point P. Okay, what is the electric field on along z direction? Okay, this hence we can take the Ez. Kqz upon z square plus r square. Bracket is to how much? Bracket is to 3 by 2. Bracket is to 3 by 2. We can take some condition here. Okay, what is the first condition? First condition is suppose we can take z tends to infinity. Z tends to infinity. Z is a very, very large. Then, and second condition, Z tends to 0.
Yeah, Z is infinity, Ez is equal to 0. And as Z is equal to 0,
into G2,
Ez is equal to EQZ divided by R cube.
R cube.
At Z is equal to how much? 0. At Z is equal to 0, electric field E is equal to, yes?
A cube Z upon R cube.
KQ upon R square.
Towards the z.
Sorry. At Z tends to 0, electric field
0.
Electric field 0. Okay. It tends to very, very large. It tends to very, very large. Then E tends to very, very large. Z tends to very, very large. Infinity means don't take directly infinity. Z is a very, very large. Z is a very, very large. Yes. Very, very large. Yes. Z is a very, very large. Z is a very, very large. Then suppose this is a very, very large. This circle behave like a. This circle behave like a. This ring will behave like a point charge. Yes or no? Means Z cube. Sorry. First condition, Z tends to 0. At Z tends to 0, E is equal to how much? 0. Okay. And the second condition, at Z tends to infinity, or Z is a very, very large. Z is a very large. Z is a very, very large. Z is a very, very large. Then Z square plus R square, bracket is to 3 by 2, is approximately equal to.
Z cube.
It's approximately equal to how much? Z cube. Okay. Means electric field E is equal to how much? KQZ upon Z cube. Yes or no? KQ upon 1Z get cancel. This is like a KQ upon
1 z
KQ
square.
upon Z square. This is the electric field. This is the electric field of.
Point charge.
This is the electric field of a point charge. Okay.
And electric
This is the electric field of a point charge. Next. At what distance electric field is maximum? At what distance electric field is a maximum? Yes.
Derivative.
Any quantity is maximum or minimum.
Derivative is 0.
With respect to x, with respect to z. With respect to x, with respect to z.
With respect to z.
With respect to z means a dab upon dab z. What is the electric field? Electric field is equal to how much? KQZ upon z square plus r square. Bracket is to how much? 3 by 2. Yes or no? Bracket is to how much? 3 by 2. P constant, Q constant. This is equal to how much? 0. Yes or no? Because this will be, we can find out the maximum electric field. Maximum electric field at first derivative is equal to how much? 0. Means here we can take K is common out, Q is common out. Dab upon dab z. Dab upon dab z. Z upon z square plus r square. Bracket is to 3 by 2. Z upon z square plus r square, bracket is to 3 by 2. How to solve this one?
U by V.
U upon V. Yes. Z square plus
Multiplication में पण येतो.
Z square plus R square bracket is to 3 by 2. Z derivative 1. Z derivative 1
One.
minus Z as it is Z square plus R square bracket is to 3 by 2 derivative 3 by 2. Z square plus R square bracket is to how much? 3 by 2 minus 1. 1 by 2.
1 by 2.
1 by 2 upon
Z square चं derivative पण येईल ना सर 2z.
Z square plus R square to the power 3.
Z square plus R square bracket is to how much? 3 by 2 is equal to how much? 0.
3 by 2 स्क्वेअर येईल ना सर.
3 होईल ना ते
स्क्वेअर सर खाली 3 येईल ना नुसतं डिनॉमिनेटर मध्ये.
Square is
स्क्वेअर असतं ना.
square
Yes.
आणि तो पुन्हा cancel होईल. To the power 3.
3 होईल ना ते.
This is going to this side. This become
सर खाली square येईल square. यानी कि Z square plus R square to the power 3.
Z square plus R square bracket is to how much? 3. Yes, square will cancel with. And this is going to this side. This become 0. Okay. Next, from this equation we can take common out. From these two equation we can take common out.
स्क्वेअर प्लस आर
Z square plus R square power 1 by 2.
is to half.
1 by 2 we can take common out. What is the remaining here?
Z square plus R square.
Z square plus R square. Yes or no? Bracket is to 1. Or simply we can write down the Z square plus R square. Minus. Minus, yes. 1 by 2 already over.
3. 3 Z square.
Square 3Z square sir.
Okay. 3.
तो cancel होईल.
Z square.
Square.
Yes. Z square. Z square plus R square
Is equal to
minus 3 by 2. Sorry. 3. Z square is equal to how much? 0. Second part. Okay. We can take second part only. Yes.
R square minus 2Z square equal to 0. R is equal to 2Z.
R square is equal to 2Z square. R square. Z is equal to R divided by root 2.
By root 2. Yes or no? Or by root 2. This distance we getting electric field.
Maximum.
We getting electric field.
Sir, root 2 येईल ना ते?
R by
Plus or minus?
root 2 will not. Z is equal to minus, so don't take minus. Yes or no? Because distance is never negative. Means here is simply R upon root 2. This value we getting electric field is a maximum. Yes or no? Electric field is maximum. Yes or no? My electric field okay. We can substitute Z value in electric field, we getting the maximum electric field. Okay. Means at this distance we getting electric field is a maximum. Yes or no? Disk. System is a disk. Okay. System disk. What is the electric field at a point? Z. Disk is a
2D.
infinite number of
Rings, no?
infinite number of rings? Yes or no? Means what is the electric field at a z distance? What is the electric field at a z distance? Because of small d is equal to, yes, how much? K dq upon, yes,
Z upon
K
square root
Q
of Z square
z square plus
Z square plus R square raised to 3 by
bracket is to how much? 3 by 2. Yes or no? K dq upon z. Here, so this r is a small capital.
small.
Small, yes or no? Because this r is a variable, yes or no? Bracket is to 3 by 2. Yes or no? K dq upon z square plus r square bracket is to how much? 3 by 2. Which part will be survive? Sine part is survive, cos part, okay. Already survive everything. तेच आलं आपलं
सर्वाइव्ह करून आन्सर
सर्वाइव्ह करूनच आलं आन्सर. ओके. हां, देन इलेक्ट्रिक फील्ड E is equal to, yes, E is equal to integration K dq z upon z square plus r square bracket, sorry, smaller r square K dq z upon z square plus small r square bracket is to 3 by 2 into system 1D 2D 3D
2D ना
2D means this is equal to how much? Into dA. Okay, what is the value of dA? dA
0
z square plus r square bracket is to how much? 3 by 2 into dA is how much? rdr into integration d phi. rdr.
सिलेंड्रिकल नाही किंवा सिस्टम
काय येईल ना
दोन्ही सेमच आहे ना स्फेरिकल आणि सिलेंड्रिकल 2D सेमच सांगितलं ना सर तुम्ही
Yes, next. System is a 2D. System 2D. Sigma. Sigma is equal to how much? dq upon dA. Sigma is equal to how much? dq upon dA. Then dq is equal to how much? Sigma dA. Yes or no? dq is equal to how much? Sigma dA. K sigma z upon z square plus r square bracket is to how much? 3 by 2 into dA value. dA value. dA rdr d theta.
theta
rdr d theta. K constant variable. Sigma constant variable. Sigma nothing is mentioned by default. This one is a uniform charge distribution. Z also we can take common out. R upon z square plus r square bracket is to how much? 3 by 2 dr into d phi. D phi limit 0 to 2 pi. R varying from here R value 0, here R value capital R, 0 to capital R. D phi integration 2. This is equal to how much? 2 pi sigma z. 2 pi sigma z limit 0 to capital R. R upon z square plus r square bracket is to how much? 3 by 2 into dr. How to solve this integration?
मायनस काल सांगितलं होतं सॉरी
हा काय ते फॉर्म्युला
Something nothing.
नथिंग
2 pi sigma z. 2 pi sigma z
मायनस
minus something nothing minus 1 upon
आर अपॉन
z square plus r square bracket is to 1 by 2 limit 0 to capital R.
डिनॉमिनेटर मध्ये पण एक झेड येईल ना आर येईल ना
नाही येणार नाही
something
नाही येणार का
something nothing.
ओके सर
Higher limit 2 pi sigma z, yes, higher limit 1 upon r is equal to 0 means 1 upon z minus
minus 1 upon
r square plus z square bracket is to how much? 1 by 2. Okay, minus, interchange the limit. Okay, here minus become plus, limit r to 0. R to 0. We can substitute 0, r is equal to 0, simply z square. Square get cancelled. Square minus this one. This is the electric field because of a ring. A ring electric field. 2 pi sigma z. Yes. Here we can take sigma inside, z inside. Then
सर ते इंटिग्रेशन कसं घेतलं तेवढं सांगा ना.
something nothing. Also formula something nothing. Z square plus r square. Z square plus r square. Yes or no? This is the electric field arise because of the. This is the electric field arise because of. Because of this.
P1 ring.
Because of this. Yes or no? Because of what?
हे कुठे गेलं? हे कुठे गेलं?
काय? 2 pi sigma 1 minus z upon z square plus r square. Z upon under root z square plus r square. Next, we can take again condition. Case number 1. Case 1. Z tends to 0.
Center of the disk.
Yes, center of the disk.
सर ते आपल्या इंटिग्रेशन मध्ये के होता तो कुठे गेला?
नाही के बाहेर आहे इंटिग्रेशन मध्ये. हा तिथे
कोण? अहो काय सांगितलं. हो सर का थोडं पाणी द्या ना प्यायला. मी लावतो काही नसतं. तुम्ही जरी नसते ना मी आलो असतं लावून. तुम्ही मला फोन नाही.
Two pi k. K is nothing but. K is nothing but.
1/4 pi तेच ना?
Yes, sir. 2 pi
1/4 epsilon naught.
4 pi epsilon naught. Okay. 1 minus z upon under root z square plus r square. Z square plus r square. Okay. Which part get cancelled? Pi get cancelled. 1 to 2 get cancelled. E disk is equal to. E disk is equal to sigma upon epsilon 2 epsilon naught 1 minus z upon under root z square plus r square. Z square plus r square. Bracket is to 1 by 2. Okay. R tends to infinity. Yes, up to here any problem?
No sir.
No sir.
R tends to infinity. Yes, what is the value of E? लक्षात ठेवा व्यवस्थित आहे. Sigma upon epsilon 2 epsilon naught 1 minus z upon under root. Yes, z square plus r square. Z square plus r square. Yes or no? We can take infinite radius. Infinite radius. Infinite radius means r tends to.
Second term 0.
R tends to infinity.
Second term again.
R tends to infinity. Then electric field.
Sigma by 2 epsilon naught.
Distance increases. Electric field.
Independent of distance. Constant. Independent.
This become infinite seat. Infinite
Sheet.
Sheet of charge.
infinite seat. Always memorize infinite seat electric field. Sigma by 2 epsilon. Okay, this one is an infinite seat. Here we're getting how many surfaces? One surface is two surfaces. One is this surface. Another is this one. For upper surface, sigma by 2 epsilon naught. Down surfaces, sigma by 2 epsilon. And what is the net? Total. Sigma by 2 epsilon.
Sigma by epsilon naught.
Sigma.
epsilon.
This one is not a cancel. See here. Suppose this electric field direction. This one is the electric field direction. And area vector also in same direction. Flux is not equal to. Infinite seat electric field. Infinite seat electric
Sigma by
field.
2 epsilon.
Sigma by 2 epsilon naught. Okay. Sigma by 2 epsilon naught. Sigma by 2 epsilon. Suppose we can take the bar here, then this becomes sigma by 2 epsilon naught. Direction is x cap minus x cap y
Sir,
cap.
E at the center of the disk पण sigma upon 2 epsilon naught असेल ना मग?
Where?
At the
Infinite
center of the disk.
center of disk z is to
0 ना? Z is equal to 0 ना? मग ते पण sigma upon 2 epsilon naught असेल ना?
z is equal to 0 sigma upon 2 epsilon कसं येईल? This is equal to how much? Sigma upon 2 epsilon naught. Okay, 1 minus. Suppose we can divide z. Divide z, then this become 1 upon under root. 1 upon under root. Yes.
1 plus r square by z square.
R square by z square. Okay. Z tends to 0. Z tends to
1 upon infinity.
1 upon infinity. Our z 1 upon infinity. 1 upon infinity is 0.
0.
Sigma by 2 epsilon. सेंटरला कसं काय सिग्मा बाय 2 एप्सिलॉन नाही यायला पाहिजे. सिग्मा like and like. Here, first the surface charge density is a plus, second surface charge density is a minus. Okay. Plus electric field toward away. Away, yes or no? Plus electric field, yes or no? Here is a plus charge, electric field. Plus charge, electric field. Away. Yes or no? This direction. Minus. Towards. Okay. This seat create an electric field. In which direction? Right region. Away. Here also away. Okay. and the left region, because of this one, direction is this. Okay. Minus it towards. Okay. Means
Sorry, away.
here
Towards.
minus toward. Here also toward. Here electric field is depends upon distance.
No, sir.
Here
Infinite.
electric field is not depends upon distance. Okay. Means the strength of electric field is constant variable.
Constant.
Yes or no? Okay. This is the electric field direction for sigma plus sigma minus. E plus E minus.
E minus.
Okay. Because of this one. Okay. E minus suppose. And this is because of E plus. Here.
E plus.
E minus. This is because of E plus. E minus.
E
E
minus.
plus.
E plus.
Find out the electric field at the region first, second, third. Find out the net electric field at first region. First region E plus plus E minus. E plus plus
0, 8, no?
E minus. Okay. Here electric field E minus is equal to, yes, E minus is equal to how much? Sigma upon 2 epsilon naught. Direction.
X cap.
Direction. Here arrow is up toward the positive direction. Positive direction plus X cap. Okay. Next, here is the E plus away from this one. E plus sigma upon 2 epsilon naught. Direction. Direction minus
Minus
X
X.
cap. Second region. Sigma upon 2 epsilon naught. Sigma upon 2 epsilon naught. Direction plus X cap. Direction plus
Plus
X
X.
cap.
Plus X.
Here E minus sigma upon 2 epsilon naught. Direction minus X cap. Here sigma upon 2 epsilon naught. Direction plus X cap. Net E plus plus E minus. For first region E plus sigma upon 2 epsilon naught minus X cap. Plus second one sigma upon 2 epsilon naught plus X cap. Here sigma upon epsilon naught we can take common out, plus X cap minus X cap get cancel. Electric field in second region. Yes, second region. Sigma upon 2 epsilon naught plus X cap plus sigma upon 2 epsilon naught plus X cap. Okay. This is equal to how much? Sigma upon 2 epsilon naught 1 by 2 plus 1 by 2.
1 epsilon naught.
Electric field in second region 0 non-zero.
0.
And electric field in third region.
Inside non-zero.
Electric field in third region.
Zero.
Third region 0. Okay. Next.
0.
Plus minus minus minus. Direction. First one direction. First
Away.
direction away.
Away.
This. Away means any distance arrow will be same. Yes or no? Because electric field is not constant at any point. Here left one. Yes or no?
Away.
Next second toward. Yes or no? Second toward. Means here also arrow is this direction. Got it? Second toward. Third one positive. Third one positive. Yes, positive. Away means this direction is away. This also away. Got it? Because of third one away. Fourth one away. Here arrow positive negative direction.
Away.
Positive negative. Here
Positive.
negative. Positive. Yes, next towards means in the direction toward means this one. In the direction toward means this one. Next last one towards. The direction is toward this. This is a toward arise because of minus sign. Because of minus sign. Okay. First plate electric field. First plate electric field. Here, this is a sigma by 2 epsilon naught. Sigma by 2 epsilon naught. Direction. First electric field direction minus x cap.
Minus x.
Next, second one sigma by 2 epsilon naught. Direction
Plus x cap.
plus x cap. Next, sigma by 2 epsilon naught. Sigma by 2 epsilon naught. Direction plus x cap. Next, sigma by 2 epsilon naught plus x cap. Okay. We're getting how many electric fields? 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4. Next, 5 sigma by 2 epsilon naught plus x cap. Next, sigma by 2 epsilon naught plus x cap. Next, sigma by 2 epsilon naught plus x cap. This is the network. Which part get cancelled? Plus minus get cancel. 1 plus 1 minus get cancel. Remaining all are plus. How many plus? 1, 2, 3, 4, 5. Means E net E first is equal to how much? 5 by 5 sigma upon 2 epsilon naught. Net direction is plus x cap. Plus x cap. Okay. Yes. What is the second, third, fourth, fifth? Second one. Here is a 2 positive. And how many negatives? 1, 2 positive. 1, 2, 3, 4. 4 negative. 2 positive, 4 negative.
5 negative. 5 negative.
3 to 5 negative, 2 positive.
Minus 3.
Minus 3 sigma upon 2 epsilon naught x cap. Direction negative. Net minus 5. Okay. Plus lambda plus 2 lambda. Sorry, minus 3 plus 4 minus 5. Okay. Yes, Bula. Next one. Third. Negative 1, 2, 3 negative, 4 positive. 3 negative, 4 positive.
Sigma by 2 epsilon naught. X 2 epsilon naught plus x cap.
Plus x cap. Next. E4, E3, E4. E4 1, 2, 3, 4. 4 मध्ये 4 मध्ये
Sigma by epsilon naught minus x cap.
1, 2, 3 positive, 4 negative. Means sigma by 2 epsilon naught minus x cap. Minus x cap. 5 1, 2, 3, 4, 5 positive, 2 negative. 5 positive, 2 negative, 3 positive. Means 3 by 2 sigma by epsilon naught. Okay. Problem digest होतोय का?
Yes, sir.
Okay. Next problem घेता येईल. Yes, बोला. Direct 1, 2, 3, 4 लावूया. 1, 2, 3, 4, 5. Yes. But first plus, second minus, plus असं का? Plus minus, plus minus. Okay. Plus 1, minus 2, plus 3, minus 4, plus 5. Yes. Fast. Solve this one. E is equal to yes. Sigma by 2 epsilon naught. 2 sigma by 2 epsilon naught. Next, E is equal to 3 sigma upon 2 epsilon naught. Got it? This is the electric field creating because of this plate. Yes or no? First plate, electric field, this one. Second plate, this one. And so on. E4, 4 sigma upon epsilon naught. So, let's find out fast. Yes. Yes, what is the value? Second direction. Second direction. It is a plus sign, plus away. Minus 3 lambda. Last one. Am I audible? आवाज येतोय?
Yes, sir.
आवाज येतोय सर.
Okay, last one. Minus 3 lambda. Direction. Minus 3 lambda direction. Toward. Yes. Any doubt? Here.
No, sir.
एखादा पॉइंट सॉल्व करायचा या केस मध्ये. Suppose you can find out the electric field in this region, okay? Then this is equal to how much? This is the third region, suppose. Third region. Here is in the negative direction. This arrow in negative direction. What is the electric field for this case? This is the negative direction because of first place. Because of first plate. What is the density? Minus 2 lambda. Means minus 2, or we can take the direction is a minus 2 sigma epsilon naught sigma upon 2 epsilon naught. Yes or no? Direction is minus x cap. Next, this is a positive. This one is positive because of first plate, second plate, third plate. Positive because of this arrow, because of which plate?
Third plate.
Second plate. This is because of second plate. What is the second plate? 2 lambda. Yes or no? This is equal to how much? Sigma is equal to 2 lambda. It's 2 lambda. 2 lambda upon 2 epsilon naught. Direction is how much? Plus x cap. Next. Third arrow because of 3 lambda. And this is equal to how much? 3 lambda upon 2 epsilon naught. Direction minus x cap. Got it? Fourth arrow in positive direction. Fourth arrow arise because of
minus 3 lambda.
minus 3 lambda. Means 3 lambda upon 2 epsilon naught. The direction is plus x cap. Got it? Direction arrow positive direction. Here is a minus.
डायरेक्शंस एक बार बताओ.
कौन सा? Yes, any doubt?
सर 3 लैम्बडा का डायरेक्शन.
कौन सा 3 है? Plus 3 lambda, minus 3 lambda.
प्लस 3.
Plus 3 lambda means away from this one. Here the charge is positive. Okay, arrow outward direction. Yes or no? Means here is a plus 3 lambda. Plus 3 lambda away. Means the direction away means positive direction. In this plate on here away means negative direction.
सर फिर टोटल डायरेक्शन माइनस x कैसे लिया?
टोटल कैसे कहाँ माइनस ले लिया है?
यहाँ इक्वेशन में माइनस x कैप.
थर्ड में. हाँ तो थर्ड में क्या है? ये एरो कौन से डायरेक्शन में चल रहा है? या पॉजिटिव, नो प्रॉब्लम, बट दिस पॉजिटिव arrow away from this one. Okay, means electric field in this region in negative direction.
और राइट साइड वाले एरोस मतलब टोटली अवे है ना, कोई भी डायरेक्शन में हो सकता है वो.
नहीं, कोई भी मतलब कौन से रीजन में देख रहे हैं? सपोज ये प्लेट है, ठीक है, हम यहां देखेंगे तो डायरेक्शन प्लस एक्स कैप माइनस एक्स कैप. प्लस एक्स कैप in this region. Here direction is माइनस एस स्क्वायर। या ऐसे मत सोचो कि यहाँ पॉजिटिव है तो पूरा आंसर मतलब जो भी एरो रहेंगे हमारे पॉजिटिव आएंगे, नेगेटिव मतलब ऑल नेगेटिव्स ऐसे नहीं आ सकता। ठीक है, हम कौन से रीजन पे इलेक्ट्रिक फील्ड दे रहे हैं इसके हिसाब से पॉजिटिव या नेगेटिव आ जाएगा। ठीक है, here charge is positive, we can take this side, all are positive, this side all are negative. Suppose we can take the minus here, minus charge means toward, okay, means here direction is minus x square, here direction is plus x square, means we consider in this region we getting minus sign, we consider in this region plus sign.
सर तो वो रीजन कैसे डिसाइड करना है, क्योंकि या तो अवे और टुवर्ड्स दोनों में भी पॉजिटिव नेगेटिव आएंगे।
रीजन कैसे डिसाइड करेंगे, मतलब हम सपोज 1 by 1 सॉल्व कर रहे हैं, हमें इस रीजन में फाइंड आउट कर रहे हैं, उस रीजन में फाइंड आउट कर, इस रीजन और रीजन में फाइंड आउट कर रहे हैं। ठीक है, नहीं तो एग्जाम में कोई तो 1 रीजन दिया जाएगा कि फर्स्ट रीजन में फाइंड करो, सेकंड रीजन में, थर्ड में, इसलिए हमने जनरल ले लिया कि थर्ड रीजन में हम फाइंड आउट कर रहे हैं। ठीक है, और जो पहला है दूसरा एग्जाम्पल था इसमें हमने क्या कर दिया, तीनों में रीजन में फाइंड कर दिया, फर्स्ट रीजन, सेकंड रीजन एंड थर्ड रीजन। ओके, यहां भी हम वैसे ट्राई कर रहे थे। ठीक है, तो इसका मतलब ये मतलब जनरली तो पूरा सॉल्व करना चाहिए। ठीक है, लेकिन एग्जाम के लेके तो कोई तो एक रीजन दिया जाएगा, वो कौन सा भी हो सकता है।
तो अभी वाले एग्जांपल में हम कौन सा रीजन यूज करें?
थर्ड रीजन, ये वाला,
बिटवीन सेकंड एंड थर्ड प्लेट।
बिटवीन सेकंड एंड थर्ड प्लेट, यस।
ओके ओके।
इसलिए वो प्लस और माइनस, एरो जिस डायरेक्शन में चल रहा है वो प्लस माइनस। गॉस लॉ, यस, गॉस लॉ,
इंटीग्रेशन ओवर क्लोज लूप
ds is equal to rho upon
क्लोज इंटीग्रल e bar dot ds bar, yes or no?
q upon epsilon naught
E bar dot ds bar, yes or no? Means this much amount of flux passing through this area, this much amount of this must be close, always memorize. Okay, how much flux passing through this region, high amount of flux passing through this region. Okay, or we can take phi is equal to how much, q enclosed upon epsilon naught. Okay, suppose कोई कौन सा भी चार्ज हम enclose करेंगे तो इसमें कितने फ्लक्स पास आउट हो जाएंगे इस रीजन में, हाई अमाउंट ऑफ फ्लक्स पास हो सकते हैं, लेकिन दिस एरिया मस्ट बी enclosed. Okay, or the charge must be enclosed. Number 1, number 2. Both equation left sides equal, unequal.
equal
A is equal to B, A is equal to C, implies that
A is equal to C.
B is equal to C.
Equal to
Okay, means close integral B bar dot ds bar is equal to Q enclosed upon epsilon naught. Here enclose word is a very important. Okay, here is no enclose. Close integral E bar dot ds bar is equal to how much? 0. Charge is not enclosed. Then how much flux passing through this one?
the charge.
0. What is the meaning of 0? Suppose we consider this one is charge is Q. Okay, charge is Q. Here flux is equal to 0 means no any flux created by this plus Q charge. This is not like that. Okay, here is a plus charge, definitely this is creating some flux. Yes or no? But we consider this one is a region. Okay, we need to find out how much flux passing through this one. What happened here? This is suppose 5 flux incident on this. Same 5 flux passing through this area. Yes or no? Outside. Okay. What is the net flux here? Here phi is equal to how much? 0. Why phi is equal to 0? Because here incoming is equal to outgoing flux. Incoming flux is equal to outgoing flux. When charge is not enclosed. And suppose charge is enclosed. Means here is, suppose the charge is creating 10 flux. 10 flux is only going outside. Yes or no? Emitting from this source. Yes or no? Means here flux pi is not equal to 0. But here flux pi is equal to 0. Why? Because here incoming flux is equal to outgoing flux. Hence, charge is not enclosed, total flux is equal to how much? 0. Got it? Next. Close integral E bar dot ds bar is equal to how much? Q enclosed upon epsilon naught. Q enclosed upon epsilon naught. Okay. Now, suppose here is a point charge Q. The charge create a electric field. The charge is creating electric field in this direction, all direction. Yes or no? All direction. Suppose we need to find out what is the electric field at a point P. What is the electric field at a point P? P point is here. Okay, this distance is suppose 2 meter. This distance is 2 meter. Suppose we getting X amount of electric field at a point P. X amount of electric field at a point P. What is the electric field at BCDA? BCDA. B also at a 2 meter distance. C also at a 2 distance. Means all points at a 2 meter distance. What is the electric field value? Same, different? Yes or no? Suppose we can take the bulb is here. Okay. Or we can take here one bulb. We can find out the how much rays incident on this region, suppose. Okay. Here we are getting X value. At the same distance here. Same amount of rays incident on this one or different one? At the same distance. Here. Here. At the same radius. Strength of this rays, same or different? Same. Yes or no? Similarly, here also at a point P, at a point B, C, D, A, all points are at the same distance. Electric field at each and every point on this one, same or different? Same. Constant variable. Means on this distance, constant variable? Constant. Yes or no? This is the C. Yes or no? Each and every point on this circle. Okay? Now. Here is a plus Q charge. Okay? Electric field creating around of this one. This one. Electric field is creating around of this one. Now, the charge creating electric field in which direction? All direction. Yes or no? All direction. Then this system become 1D system, 2D system or 3D system? 1D, 2D, 3D. This system become a 3D system. Yes or no? This system become 3D. 3D system. This rays is emitted from this charge. Yes or no? Means we can measure this rays on length, on area, on volume. ते कशावरती मेजर करता येते आपल्याला? लेंथ वरती, एरिया वरती, व्हॉल्यूम वरती करतात.
व्हॉल्यूम होती 3D म्हटलं
रेस कुठं मेजर करू आपण? या पॉइंट मध्ये मेजर करता येते. सपोज दिस रिजन. ओके. दिस रिजन is a 1D, 2D, 3D. यामधून काय होत आहेत? पास होत आहेत. बरोबर आहे. पास होत आहेत म्हणजे सपोज एखादा कोणताही रिजन कन्सिडर केला तो काय असेल? 1D असेल, 2D, 3D?
2D
सरफेस असेल, 2D असेल. येस ऑर नो? हिअर इज अ 2D सिस्टम. ओके. सिस्टम 3D बनेल. बरोबर आहे. पण यावरती कुठून आपले रेस पास होतील? तर सरफेस वरून पास होतील. येस ऑर नो? सरफेस वरून पास होत असतील तर आपल्याला ती 1D सिस्टम कन्सिडर करता येईल, 2D, 3D? 2D मध्ये कन्वर्ट. ओके. मग 2D लेंथ, एरिया, सरफेस. एरिया इज इम्पॉर्टंट. येस ऑर नो? एरिया. ऑन स्फियर, strength of electric field, constant variable. On sphere, strength of electric field, constant variable. constant. R is a fix. Okay, for the particular sphere, R is constant. Okay, at that time, electric field is constant variable. Electric field also constant at that point, at that distance. Okay, now see here, close integral. Suppose charge Q is here. Okay, electric field is creating in this region. Okay, we consider R is a radius. R is a radius. Okay, and we consider this one is area. This one is a area. Area A. Area A. Then we can use the Gauss law here. Gauss law, close integral. Close integral E bar dot ds bar is equal to E bar dot ds bar is equal to how much? Q enclosed upon epsilon naught. Okay. Now this Q charge is enclosed by this surface. Yes or no? This Q charge is enclosed by this surface.
Yes.
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 Means this Gauss law is applicable here. Okay. Q enclosed upon epsilon naught is equal to close integral E bar dot ds bar. Close means the charge is enclosed. Yes or no? Now, see here. Each and every point on, suppose this surface considered as a Gaussian surface. This surface considered as a Gaussian surface in Gauss law. Okay. This surface is known as Gaussian surface. Yes or no? This surface is known as a Gaussian surface. Okay. Gaussian surface. Gaussian surface. Each and every point on Gaussian surface, electric field is constant variable.
Constant.
Constant.
On Gaussian surface, electric field constant variable. Electric field is a constant. Okay. Each and every point on Gaussian, electric field is constant. Okay. Now, second one. Rays emitting from this one. Yes or no? Flux is emitting from this source. Okay, this one is a sphere. What is the rays direction or what is the flux direction here? Radial or normal to the surface. Yes or no? Means what is the direction of flux? Same the direction of electric field. Yes or no? Suppose we consider this one is the electric field direction. This is the electric field direction. Yes or no? This is away from the source because here we consider the plus charge. And this is away from this. This is a normal to the each and every point. Normal to the surface. Yes or no? This is the electric field direction. Always normal to the surface. Yes or no? Normal to the surface. First one. This is the electric field direction. Second one. Area vector direction.
Area vector is perpendicular to the surface.
Perpendicular to the surface.
In this case.
Yes or no? Perpendicular to the surface. Suppose we can draw area is here. Area is here. Then area vector direction. We can say this one is area vector. Area is this one. Area direction.
In this case, electric field and area vector both are in same direction.
Okay. This again normal to the surface. Yes or no? Normal to the surface. Area vector direction. Suppose this one is x-axis. This one is a y-axis. Means area in xy plane. Area in xy plane. Then area vector direction.
R bar illa sir, xi cap plus yj cap.
Toward you. Toward you. This considers x plane, x direction. This is a y direction. And area is enclosed by xy plane. Then area vector direction, z direction or toward you. Yes or no? Similarly here, this is the direction of area vector A bar. Okay? This point, area vector, same different. Same. Here also, area vector same. Means on this surface, area vector and electric field vector direction is same. Same means these two quantities are parallel to each other. These two quantities are parallel to each other means what is the angle between them?
0.
Angle between them, theta is equal to 0. Theta is equal to 0, cos 0.
1.
Cos 0, 1. Got it? Cos 0, 1. Then, suppose we consider this one is normal to the surface. What is the direction here? Suppose this is a spherical system. Then electric field E bar is equal to yes, E R R cap. Yes or no? E R R cap. In spherical system, in the direction, which component is variable? R is variable. Direction, R cap. Similarly, dA bar is equal to, dA bar also varying in which direction? Area vector in R cap direction. Yes or no? dr, dA, R cap. dA, R cap. Got it? Next. E bar can be written as E R cap dot dA R cap is equal to how much? Q enclosed upon epsilon naught. Q enclosed upon epsilon naught. Next, EDA, yes, R cap dot R cap. Q enclosed upon epsilon naught. Yes. R cap dot R cap.
1
A bar dot B bar is equal to mod A mod B cos theta. Mod A mod B cos theta. R cap dot R cap. R cap dot R cap is equal to mod R cap cos 0. Mod R cap, magnitude of unit vector. Name indicate 1. Yes or no? This is equal to how much? Theta is equal to 0, and we can write down this one. Or simply we can write down EDA cos theta. EDA cos theta is equal to how much? Q enclosed upon epsilon naught. Q enclosed upon epsilon naught. Okay? Means each and every point, cos theta is equal to how much here? Theta is equal to 0. And this is equal to how much? EDA is equal to Q enclosed upon epsilon naught. Each and every point on Gaussian electric field, constant variable.
constant.
Each and every point on Gaussian surface, electric field is constant. Electric field is constant. Electric field is constant. Okay, electric field is constant. Then integration EDE S, suppose you can take S here, Q enclosed upon epsilon. Q enclosed upon epsilon. Now here E is constant variable. E is constant where? On this surface. On this surface. Yes or no? Means here constant part take common out. E is constant. Okay. E constant. Where is constant? On surface. Okay. Integration ds. Integration ds is equal to how much? Q enclosed upon epsilon naught. Q enclosed upon epsilon naught. ds. Area. Okay. This is a depends upon system. This is depends upon system. System Cartesian. Then dx dy. System cylindrical. Dx dy. D rho. Yes, d rho d phi. Or system is a spherical, then spherical system area. Spherical system area. Spherical system area. On surface, R is constant variable. On surface, R constant variable. R is constant. Which component are variable on surface? Theta and phi is a variable. Yes or no? Theta and phi is variable. The length element for theta and phi. R d theta, R sin theta, d phi. Got it? Here R is constant, hence we can take R is capital 1. Okay? R is capital 1. R is capital. Okay? Don't take small because on surface R value is a constant. R d theta, R sin theta d phi. Got it? System is spherical on sphere. R is a constant. Okay? Means R square we can take common out. Integration d theta or sin theta d phi. Sin theta d phi. Sin theta d phi. Sin theta d theta d phi. D phi integration. Always memorize 0 to 2 pi. Then d phi integration 2 pi. Limit 0 to pi. Sin theta d theta integration. Always memorize 2. 0 to pi sin theta d theta 2. 0 to 2 pi d phi 2 pi. 2 pi 2 pi 2 pi 2 4 pi into r square into r square. Okay? Or we can take small r. Always memorize for Gaussian surface. Gaussian surface, always we can take radius is small r. Radius is always small r. Then close integral E bar dot ds bar is equal to q enclosed upon epsilon naught. Yes, E bar is constant, take common out. ds q enclosed upon epsilon naught. ds is equal to how much? 4 pi. Always small r square is equal to how much? 1 epsilon naught. Means electric field E is equal to how much? 4 pi epsilon naught. 4 pi epsilon naught. Q upon 4 pi epsilon naught. R square. R square. Or we can write down E is equal to how much? 4 pi epsilon naught is nothing but K. KQ upon R square. This is the electric field arise of which charge? Arise because of point charge. Yes or no?
Point charge on the Gaussian surface.
Yes or no? This is the electric field because of point charge. बरं, या केसमध्ये सगळ्यात महत्त्वाचं लक्षात आलं, इलेक्ट्रिक फील्ड ऑलवेज नॉर्मल टू द Gaussian surface. Area vector normal to the Gaussian surface. What is the angle between them?
0.
What is the angle between them? 0. Theta is equal to 0. Cos 0, 1. Electric field on Gaussian surface. Electric field on Gaussian surface is constant. Yes or no? Constant. We can take common out. We can find out only integration for area. And what is the area for spherical system? 4 pi r square. Cylindrical system. 2 pi r. Okay, means system is change, area also change. Got it? E bar is equal to how much? E r cap. Okay. A bar is equal to how much? E r cap. And what is the angle between them? Theta is equal to how much? Theta is equal to 0. Means E bar dot A bar is equal to how much? EA cos theta. Theta is equal to 0. Means this is equal to how much? Simply. That's it. Point charge Q. What is the electric field at a point P? At a distance R. What is the electric field at a point P? At a distance R. Yes.
Q upon 4 pi epsilon naught r square.
E is equal to Q upon 4 pi epsilon naught R square. Direction of electric field E bar. Direction R cap. Yes or no? E bar direction R cap. Point charge, electric field is this one. Yes or no? Why we can take directly Q here? Because all charge is enclosed by Gaussian surface. Yes or no? All charge is enclosed by Gaussian surface. Now, next. Suppose we can take this one is a solid cylinder. We can take a solid sphere. but inside density is constant. Inside density is constant. Inside rho is equal to C constant. Close integral. Gauss law. E bar dot ds bar is equal to E bar dot ds bar is equal to yes. Q enclosed upon epsilon naught. Yes. Electric field. Electric field. Electric field. Normal to the surface. Area vector. Normal to the surface. Angle between them.
0.
Angle between them. 0. Okay. Point is here. Point is here. I mean this one is a Gaussian surface. Yes or no? Each and every point on Gaussian. Electric field.
Constant.
Electric field constant. Take common now. ds is equal to q enclosed upon epsilon naught. Okay. This ds is the area of the system, area of the Gaussian. This area is always Gaussian area. Gaussian are always we can take small r's. Always Gaussian surface. Radius we can take a small r. Yes, into 4 pi r square. Yes. For any case of the spherical system, LHS, same or different? Same. Okay. Means system is spherical. Directly we can take e into 4 pi r square. But how to get e into 4 pi r square? Always memorize this thing. Normal, theta, 0. Got it? LHS, any problem? LHS, any doubt? No. Come to the right side. 1 upon epsilon naught. 1 upon epsilon. Here's the two condition. One condition is suppose small r is less than capital R. Capital R is the radius of the sphere. Capital R is the radius of the sphere. Okay. Now this one is a sphere. This one is a sphere. Now we can find out the electric field. Number 1. Small r is less than capital R. Small r is less than capital R means this point is inside the body, outside the body. Inside the body. Means this is a point P. This one is a point P. Draw the Gaussian. Gaussian is this one. Now Gaussian surface is inside the body, outside the body? Inside the body. Okay. LHS always into 4 pi r square. Gaussian surface inside the body, outside the body, on the body. All times we can take small r. Okay. Is equal to 1 by epsilon naught. 1 by epsilon naught. Now 100% charge is enclosed by this Gaussian surface. Yes or no?
Yes, sir.
This Gaussian is enclosed 100% charge.
No, sir, no.
This here, capital R is the radius of the charge. Radius of the sphere. 100% charge. Radius is capital R. Now Gaussian surface is this one. Gaussian surface is this one. Then this Gaussian enclosed 100% charge? No. Yes or no? Definitely this is a less than. Means here, how we can take a Q here? Because here Q enclosed is equal to Q. Q enclosed is equal to how much Q? Means how much charge? Total charge enclosed by this Gaussian. Yes or no? 100% charge is enclosed by Gaussian, then we can take Q enclosed is equal to simply Q. Yes or no? But here, not 100% charge is enclosed by this Gaussian. Then, how to find out this one? System is 1D, 2D, 3D. 3D. Yes or no? Means here volume increases charge. Means this is depends upon volume also. Yes or no? Then rho is equal to how much? Ready? Rho is equal to
Integration.
Rho is equal to dq upon
Okay. dV.
dq upon dv, because system is a 3D. Then dq is equal to rho dv. Rho dv. Yes or no? Means dv changing, rho also changing. Volume is changing, rho also changing. Means Q is equal to rho into dV. Rho into dV. Yes or no? Rho, uniform, non-uniform? Nothing is mentioned by default.
Uniform.
Nothing is mentioned, means rho is constant. Constant take common out. Okay.
Outside.
dV. Don't
Square
cancel.
theta d.
Derivative integration here. Don't cancel derivative integration here. Okay. dV r square dr
Sin theta d theta d phi.
sin theta d theta integration d phi. Limit 0 to pi. Limit 0 to 2 pi. System is 3D. Theta varying from 0 to pi. Pi varying from 0 to 2 pi. This part is equal to how much? Sin theta d theta integration.
और पाय आर स्क्वेअर आहे ना ते तेवढी क्वांटिटी
4 pi.
Sin theta d theta 2 d phi integration 2 pi. Okay. Into integration rho into r square dr. R square dr. Now this small r is varying from where to where?
0 to small r.
This charge enclosed up to how much radius? Gaussian radius. Okay, not a body radius. This charge enclosed 0 to this point. Yes or no? 0 to this point. Means here limit is 0 to small r. Yes or no? 0 to small. Last case we cannot find out the integration. Why? Because here we can take point is outside. Point is outside means whole 100% charge is enclosed. Here 100% charge is not enclosed by this Gaussian. Okay. Hence we can take the radius or limit 0 to small r. This is equal to how much then? 4 pi rho r square integration r to the power 3 upon r to the power 3 upon 3. Yes or no? This is this much amount of charge enclosed by Gaussian surface. Yes or no? This much amount of charge enclosed by Gaussian. Q 4 pi rho r cube. Then LHS into 4 pi r square into 4 pi r square is equal to how much? 4 pi rho r cube upon 3 upon epsilon naught. Okay. Which part get cancelled? 4 get cancelled. R square get cancelled. Pi get cancelled. Means rho is E is equal to how much? E is equal to rho r upon 3 epsilon naught. Rho r upon 3 epsilon naught. Means here electric field is depends upon.
Gaussian radius, Gaussian surface radius.
This is the depends upon rho. This is does not depends upon rho. Why this is does not depends upon rho? Because rho is a constant.
Constant.
Yes or no? Any point on this body, rho is constant. Means is does not depends upon rho. Second, rho is depends upon 3. No. This also constant. Epsilon naught constant. Means is only depends upon R is changing. What happened?
Field change.
R is changing. What happened? Why it changes? E का change will?
R is the only variable.
Field lines passing per unit area changes, na flux changes.
तर इनसाइड बॉडी घेतलाय ना आपण. इनसाइड बॉडी घेतलं आणि चार्ज युनिफॉर्म नाहीये.
Uniform charge density is uniform.
चार्ज युनिफॉर्म आहे पण
So in this case, electric field is directly proportional to R. As R increases, E also increases.
Yes, but why?
Number of
चार्ज increase होईल ना सर.
R increases.
Include charge increase.
R increases. Electric field depends upon charges. Yes or more the charges, more electric field. Here R increases. What happened? Number of charge enclosed by this Gaussian is increases. Yes or no? This is increases. Charge increases. Electric field increases. Got it? Means R increases means charge increases. Charge increases. Electric field is increases. Up to where? Up to
Up to capital R.
Capital
Up to
R.
capital R.
Next, again R is increases. Electric field
Decreases there.
decreases. Why? Because there is no charge. No charge. Electric field decreases. Distance increases. Electric field decreases. This is the electric field. Inside, outside.
Inside.
E in is equal to rho r upon 3 epsilon naught. Got it? System.
Spherical, na?
System. Sphere. Electric field inside rho r upon 3 epsilon naught. Got it? Inside R changing, number of charges is increases. Number of charges increases, electric field increases. Got it? Or what is the electric field inside? E in is equal to rho r upon 3 epsilon naught. Rho is charge density. Rho charge density. Okay. What is the rho value? Rho is equal to Q upon V. Q upon V. Q is a total charge. Q is a total charge. Total charge capital Q upon volume 4 by 3 pi r to the power 3. R to the power 3. Okay. Means E in is equal to rho. Rho is equal to Q by 4 by 3 pi r to the power 3 into 1 by 3 epsilon naught. 1 by 3 epsilon naught. Oh sorry, r by 3 epsilon naught. Which part get cancelled? This 3 get cancelled. QR upon 4 pi epsilon naught r to the power 3. 1 by 4 pi epsilon naught is nothing but KQR upon R cube. KQ small r upon R cube. Dimensionally this one is correct?
Yes, sir. Correct.
Yes. General electric field KQ upon R square. KQ upon R square. Yes or no? Dimensionally 1 meter get cancel. We getting KQ upon R. This R is a constant. Q constant. K constant means E in directly proportional to R. Small r is greater than capital R. Small r is greater than capital R means Gaussian surface inside the body, outside the body.
Outside.
Outside the body. Okay. This one is a body. Okay.
Okay, sir.
And this is the Gaussian surface because small r is greater than capital R. Small r is greater than capital R. LHS using the Gauss law. Close integral E bar dot ds bar is equal to Qn close upon epsilon naught. Qn close upon epsilon naught. E constant ds. LHS always into 4 pi r square is equal to 1 by epsilon naught. 1 by epsilon naught. Q is equal to integration rho dv. Yes or no? Integration rho dv. Rho constant variable. Nothing is mentioned by default. This one is uniform. Rho by epsilon naught integration r square dr integration sin theta d theta d phi. Limit is 0 to 2 pi 0 to pi 0 to capital R 0 to capital R. But here limit is 0 to small r. Always memorize. But 0 to small r can be written as 0 to capital R plus capital R to
0 to capital R to small r.
capital R to small r. No any charge element. This part 0. This part 0. LHS into 4 pi r square is equal to yes r square integration r to the power 3 upon 3 and sin theta d theta d phi integration value.
4 pi.
No need to solve this one. 4 pi get cancel. E is equal to how much? Rho r cube upon 3 epsilon naught r square. 3 epsilon naught r square.
बरोबर आहे sir.
Okay. Rho is nothing but Q
Q upon 4 by
4 by 3 pi
pi r cube.
r to the power 3 into 1 by epsilon naught r square. Epsilon naught r square. Okay, this r cube get cancel. Okay,
Sir, it's 3 pi.
this 3 get cancel. This is equal to how much? Q upon 4 pi epsilon naught r square.
Small r square.
And this is equal to how much? Kq upon r square. Is dimensionally correct? Not correct. But in an exam they ask what is the electric field? Electric field is equal to exam मध्ये काय विचारलं जाईल? Electric field E is equal to this one. E is equal to rho r cube upon 3 epsilon naught r square. In
Rho small r by 3 epsilon naught.
E out 1 by
1 upon r square.
system sphere. Spherical system En directly proportional to R, E out directly proportional to 1 by R square. Next, the system is a non-uniform. System non-uniform.
त्याचा आन्सर किती आलं? तर आन्सर किती आलं?
Rho is
Q upon pi epsilon 0 r square का?
KQ upon R square.
KQ upon epsilon 0 r. हाँ, okay. ठीक है.
Rho is equal to KR. In which region? Zero is less than R is less than capital R. Okay, means up to body. Yes or no? Up to radius of the body. Means rho is varying from this to capital R. LHS.
4 pi small r square.
1 by epsilon naught. Q is equal to
Q and close.
Q is equal to R is less than capital R. Means this is Gaussian surface. Inside, outside. Rho into theta or rho into dV. Okay. Means E4 pi R square is equal to 1 by epsilon naught integration. Rho is equal to how much here? Rho is equal to
PR.
Rho is equal to PR. And what is the theta? Theta is equal to R square dr
R square dr sin theta d theta d phi.
d theta d phi. Rho is does not depends upon theta and phi.
4 pi.
Rho is does not depends upon theta and phi. Directly we can take 4 pi. Okay. 4 pi k upon epsilon naught integration. These are R square R to the power 3 dr. R to the power 3 dr. Limit. Inside the body, outside the body.
Small r. Inside.
Inside the body. Inside the body.
Gaussian limit.
Take which limit? Gaussian limit.
Gaussian.
Take a Gaussian limit. Okay. Inside the body. Inside the body limit 0 to small r. Okay. Next. Small r is greater than capital R. Outside the body.
Body limit.
Outside the body.
Body
Take
limit.
body limit. Take the body limit. Okay. Body limit 0 to 0 to capital R, 0 to A, 0 to B, whatever they are given body. Okay. Now here, inside the body, outside the body, Gaussian. How to decide this is inside the body or outside the body? Small r is less than capital R. Small r is less than capital R means inside, outside.
Inside.
Inside 0 to small r, capital R.
Small r.
This 4 pi get cancel. E is equal to k upon epsilon naught r square. Yes. R to the power 3 integration.
R raised to 4 by 4. Small r raised to 4 by 4.
This is equal to how much? K r square upon 4 epsilon naught. Inside the body, outside the body. This is a E in, okay? E in. Next, E out. E out means small r is greater than capital R. Small r is greater than capital R. Yes, LHS. This one is a body. Okay, this one is a Gaussian surface.
E4 pi.
LHS.
E4 pi small r square.
Integration 1 by epsilon naught
Rho beta.
or rho into beta.
Rho beta.
E4 pi r square 1 by epsilon naught integration rho
PR.
r square dr.
R square dr. Sin theta d theta d theta. 4 pi.
E into 4 pi r square is equal to how much? 4 pi k upon epsilon naught r to the power 3 dr. But here limit is important. Limit outside
0 to capital R.
0 to small r can be written as 0 to capital R plus capital R to small r. Capital R to small r. No charge element. No charge element. 0. Okay. Means this is simply we can take 0 to capital R. 0 to capital R. Okay. 0 to small r can be written as 0 to capital R plus 0 capital R to small r. Okay. 0 to small r. 0 to capital R plus capital R to small r. This part is equal to how much? 0 because this here charge is not present. E is equal to how much? K upon epsilon naught r square. R to the power 3 integration.
Capital R raised to 4 by 4.
Means K r to the power 4 upon 4 epsilon naught r square. Electric field outside, inside.
Outside.
E out is directly proportional to 1 by r square. E in is directly proportional to r square.
R square.
How to find out the E1? Small r is equal to capital R. Small r is equal to capital R. E1 means surface. Okay. E1 is equal to small r is equal to capital R. How to find out the E1? Take E on is equal to E out. E out. At what value? Small r is equal to capital R. E1 is equal to E out at small r is equal to capital R. म्हणजे काय करायचं या केस मध्ये जस्ट टेक